This is the homework review video for topic number 5 test. So number 1 gives us 2 points, 1, 7, and negative 4, 8, and then asks us some questions about some different lines. So part A asks you to find the midpoint of points A and B, which is just finding the averages of both the x and y coordinates. So add the x coordinates up, divide by 2, add the y coordinates up, divide by 2, you end up with negative 3 halves, comma negative 1 half, or negative 1.5, comma negative 0.5. Part B asks you to find the distance between the two, which means you're going to subtract the x-coordinates and square it, add subtracting the y-coordinates and square it, and then square root the whole thing. Doesn't matter which order you subtract them. I did negative 4 minus 1 quantity squared plus negative 8 minus 7 quantity squared. So you end up with 25 plus 225, which is the square root of 250, which if you plug that in your calculator, you end up with about 15.8. Part C asks for the gradient between the two of the line that connects these two. Gradient is the same thing as slope, so I just did slope formula, and you end up with a slope of 3 or gradient of 3. Part D asks you to find the equation of line L1 in slope-intercept form. So I put it in point-slope form to start. Doesn't matter which point you picked. I picked point A. So y minus the y-coordinate is equal to the slope times x minus the x-coordinate. And then I solve for y, so you end up with y equals 3x plus 4. Part E says there's now a second line, L2, that is perpendicular to the first, and they want us to find the gradient of that. So perpendicular lines have opposite reciprocal slopes or opposite reciprocal gradients. So I flipped it over and made it negative. So you end up with a slope of negative 1/3. Part F wants us to find the line of that, the equation of that line in slope-intercept form. So again, I took the point that they give us, 6, 7, and used point slope form, and then solve for y, so you end up with y equals negative 1/3 x plus 9. And then part G wants us to find the intersection, which is solving the system with these two equations. You could have used your graphing calculator, y1, y2, and find where they intersect. These were both set equal to y, so I just set them equal to each other. I cleared out the denominator and then solved for x and got 1.5. I plug that into this first equation and solve for y to be 8.5. Number 2 gives us a quadrilateral, that's a school playground, and then asks us some questions about it. Part A wants us to find the boundary line between the two sections, so this dotted line here. To do that, I needed to use, we have an angle side triangle, so I know I can use law of sines, but since I want this side, I need its opposite angle, angle A. So I found angle A, which is 180 degrees minus the two angles 34 and 51 that we know. So this angle A is 95 degrees. So then I set up law of sines. A over sine of 95 is equal to 309 over the sine of 51 degrees. And then I multiplied both sides by the sine of 95 degrees, and I ended up with 396 meters. So the length of this boundary line, rounded to 3 significant figures, is 396 meters. Part B wants us to find the angle BCD, so this angle right here. I have a side angle side triangle, so I need law of cosines. But in order to find angle C, I need to know these two sides. Since I don't, I have to find this side D first. So I found side D first by setting up law of cosines. I have D squared is equal to 396 squared plus 255 squared minus 2 times 396 times 255 cosine of the included angle, 65 degrees. And so then I solved D, this side here is 369 meters. So now I set up law of cosines again using side D and the 255 meters and the 396 that we know, 369, and found this angle C here. So I have the opposite side on the outside, 396 squared is equal to 369 squared plus 255 squared minus 2 times 369 times 255 cosine of this angle that we're trying to find. So you end up with this angle C is equal to the cosine inverse of all of this, which is just I move these two over and then divided by this thing, and you get 76.4 degrees. Part C wants us to find the area of the paved section. So we have a side angle side triangle, or on either side, side angle side, and so we can do 1/2 AB sine C, or 1/2 two sides multiplied by each other times the sine of the included angle. So I decided to do these. So I have 1/2 times 309 times 396 times the sine of 34 degrees, and you end up rounded to three significant figures. The area of this section is 34,200 meters squared. Then it asks the same question for part D for the grassed area. Again, you have a side angle side triangle, so I used these two sides and the included angle of 65 degrees. I did the same thing, rounded to three significant figures, you end up with 45,800 meters squared. And then the last part asks you for the perimeter, which is adding up all four sides. We know all of the sides except for side length AD, which I'm calling here side B. So I used law of sines on this paved section triangle to find side B. So you get B over sine of 34 degrees is equal to 309 over the sine of 51 degrees. And I found, rounded to three significant figures, that side length B is 222 meters. So then to find the perimeter, I added up 309, 222, 255, and 369 to get 1,155 meters, or rounded to three significant figures, 1,160 meters. Number 3 gives us a composite shape of a hemisphere and a right cone. Both have a radius of 28 centimeters, and the height of the cone is 84 centimeters, and then it asks us some questions. So part A wants us to find the angle BAD, so that's the angle that the slant makes with basically the radius right here. So we know the adjacent and we know the opposite side, so I use tangent. Tangent of A is opposite over adjacent, so 84 over 28. And then I want the angle, so I took the tangent inverse of 84 over 28 and got 71.6 degrees. Part B wants us to find the total volume of this shape. So I found the volume of the cone and then the volume of the hemisphere and added them together. Volume of a cone is 1/3 pi r squared h, where r is the 28 and h is the 84. So you end up with this value right here. And then the hemisphere is half of a sphere. The volume of a sphere is 4/3 pi r cubed, so then I just divided that by 2, where r is 28. So then you get the total volume to three significant figures is 115,000 centimeters cubed. Part C wants us to find the surface area. So again, I found the surface area of the cone. There's no base, so you don't have to include that. You just want to find the slant surface area, and then the surface area of half the hemisphere. So the surface area of a cone is pi rl, where L is this slant height here. So I needed to find that, so I used Pythagorean theorem to find this slant height here. So L squared is equal to 28 squared plus 84 squared. So L is 88.5. And then I plugged that in and found the surface area of the cone. And then the surface area of the hemisphere, again, is half the surface area of a sphere. So the surface area of a sphere is 4 pi r squared. And then I divided that by 2, where r is 28. Added those two together, and to three significant figures, the surface area is 12,700 centimeters squared. Number 4 gives us that Alexis is standing 2.25 kilometers away from a hill that is 563 meters high, and then asks us some questions of it. Just be aware that they give us two different units, so take that into account when you're solving this. So the first question is the angle of elevation it takes for Alexis to look up to the top of the hill, so basically this angle here. We know the two sides, we do not know the hypotenuse, so I use tangent is opposite over adjacent. So the tangent of this angle A is 563 over 2,250, because I converted this into meters. You could have also converted this into kilometers and had it be 0.563 kilometers. Either way, you should have gotten 14 degrees, 14.0 degrees when you use tangent inverse. And then part B wants us to know if she could fly straight to the top of the hill, how far would she fly? And so that would be that distance C, the hypotenuse. So I used Pythagorean theorem and got 2,320 meters, or 2.32 kilometers. So number 5 is a review question from topic number 1. It's a geometric sequence, and they want us to figure out some stuff given that the third term is equal to 10 and the fourth term is equal to 2. So part A just wants us to find the common ratio. Remember, the common ratio is any term divided by the term in front of it. So since we have two consecutive terms, we can just divide 2 divided by 10. So we are dividing by 5 or multiplying by 1/5. For part B, it wants us to find u sub 1, or the first term. So you can either go backwards a couple until you get to u sub 1, or you can set up an equation. This is the explicit form of a geometric sequence. U sub n is equal to u sub 1 times r to the n minus 1. I plugged in the fourth term is equal to 2, so I plugged in 2 for u sub n and n to be 4, and then used my graphing calculator to find that u sub 1 was equal to 250 by making this be y1 and this be y2 and finding where they intersect. For part C, it just asks us to write out the explicit formula. So again, using this, u sub 1 is 250 and r is 1/5. And then part D wants us to find the sum of the first 8 terms. You can either use your summation on your graphing calculator or the geometric sum formula. I use this, plug everything in, and you end up with 312 to 3 significant figures. So now we're getting into the sample paper questions. Number 1, we're given a square-based pyramid that the angle of inclination is 70 degrees and all the sides are 10 centimeters. So part A wants us to draw a triangle that shows us the 70 degrees, and there's a few ways to do it, but I picked triangle EMG, and so that 70 degrees was right here. This side, since it's half the side length, would just be a 5. And then part B wants us to use this triangle to find the height, or distance EM, of the pyramid. So we have this 70 degrees. We know that this side is 5, and we're trying to find this side, so we have opposite and adjacent. So I said that the tangent of 70 degrees is equal to the height that we're trying to solve divided by 5. So I multiplied both sides by 5 and got the height was 5 tangent 70 degrees, which is 13.7 centimeters, which is what we were trying to prove. Part C, I wants us to find the distance EG, so the distance of the slant. So I just used Pythagorean theorem and found that it was 14.6 centimeters. Part 2, C2, wants us to find the angle DEC. So I found the angle DEG first and then doubled it because this was a right triangle. You didn't have to do it that way. But the tangent of E is equal to side length 5 divided by 14.6. So then E is the tangent inverse of 5 divided by 14.6, which is 18.9 degrees. So that means that this whole angle DEC is twice that, or 37.8 degrees. Part D, which wants us to find the surface area, so that you just add up all the sides of the pyramid. So we need to find the area of one of these triangles. So to do that, I found this side length here, which would be all the side lengths, and found that to be 15.4 using Pythagorean theorem off of this triangle down here. And then, so the area of the triangle, we now have a side angle side triangle. We can use 1/2 AB sine C. So 1/2, both of these sides are the same length, so 15.4 times 15.4 sine of this angle that we found in part C2, 37.8 degrees. So the area of one of these triangles is 72.7 centimeters squared. The area of the base is just a square, so it's just the 10 squared, the side squared, which is 100 centimeters squared. So then the total surface area, we have 4 of those triangles at 72.7 centimeters squared and one square at 100 centimeters squared. So we end up with 391 centimeters squared for our surface area. Volume of a pyramid is 1/3 the base times the height. Well, the base is 10, and we found the height over here in part B, which was 13.7, so you end up with a volume of 457 centimeters cubed. So question number 2 gives us a leaning tower and some information about how far Leonardo is standing away from this leaning tower, and it can all be diagrammed with this triangle MTL. So part A1 wants us to find the angle BTL, so this angle up here. In order to do that, I first found this angle here. So if this is 100 degrees, this is a straight angle. A straight angle makes 180 degrees. So if this is 100 degrees, then this angle TBL must be 80 degrees. So then I subtracted 80 and 26.5 from 180 and found that angle BTL is 73.5 degrees. So then in part 2, they want us to use that to find side L, or BT here, basically how tall the tower is. So we have a law of sines triangle here, so I set up law of sines. L over the sine of 26.5 degrees, because they're opposites of each other, equals 120 over the sine of 73.5 degrees, because they're opposites of each other. I multiplied both sides by the sine of 26.5 and found that L was 55.8 meters. So the tower is 55.8 meters. Part B wants us to find how tall the tower is from the ground. So side GT, basically, if you measured it from the ground to the top, even though it's leaning, how high would that be? So I know, again, this angle TBL is 80 degrees. So I'm going to use this little right triangle BGT to help us. So we have the sine of 80 degrees is equal to the opposite, which is the height that we're trying to find, and divided by the hypotenuse, which is this 55.8 meters that we just found. So I multiplied both sides by 55.8, and you end up with this height is 55.0 meters. Part C wants us to find this distance MT here. So we have a law of cosines problem. We have a side angle side triangle. So I called this side B. So B squared is equal to 200 squared plus 55.8 squared minus 2 times 200 times 55.8 times the cosine of 100 degrees. And you end up with B to be 217 meters. So the last question is a topic 2 review question. They give us some information about how long students get ready in the morning and then ask us some questions about it. So part A, they want to know how many students total were surveyed. So you just add up all the frequencies and you end up with a total of 90 people answered the survey. Part B wants us to find the median time frame or median group. So 90 people surveyed means that the median would occur after the 45th person. So if you add these up, you end up with 6 plus 14, we're only at 20 by the time we get to this group, plus 16, we're at 36, and then when you add 34, we're at 70. So that means the 45th person happened in the 25 to 30 time range. Part C wants us to find the modal group. That's just the one that was answered the most, so again, the 25 to 30 group. Part D wants us to find the mid-interval of time 15 to 20, so you just add them up and divide by 2, or find the middle number that's right in the middle, which is 17.5. Part E wants us to find the mean and standard deviation times. So you use your graphing calculator and you enter the mid-intervals of the times as list 1, and you enter the frequencies as list 2, and you go into one variable stats and make sure you tell it that you have a frequency list of list 2, and that will give you this information, a mean of 25.3 and a standard deviation of 6.11. And then part F, they give us a cumulative frequency table, so that means you just add them up. So at 20 minutes, 20 people have answered that they did less than 20 minutes, and so on and so forth. And they want us to find A and B. So in the first group you have 6, and then they added 14 who answered in the second group. So to get this one, these 16 people have now also answered. So these 20 plus 16 more, that means 36 people have answered by this point. And then same with part B, we're at 70, and then 18 more people answered this time frame, so 70 plus 18 is 88 people would be part B. So this has been the review video for the topic 5 test.